Hello everybody, welcome to another stream. I'm still looking kind of blurry, I think. Yeah, I was going to fix that, but I'll fix that next time. So today we're going to be working on the parser for the encoding slash decoding system. So basically, let me get chat up on my laptop. No, that. There we go. Right, chat's up. Hey there, Sully. Good afternoon. Good evening. Hey there, Nick Forza. Good to see you. How you guys doing? So last stream we designed the format for this .enc, ENC file is short for encode, obviously. I'm not sure if I want to stick to this 100%. I was thinking about maybe we don't even have to specify what version it is in the file itself. But at least today we can just crack on and get a parser working, right? And then we can solve all the sort of the little the more smaller design questions that I have basically. But yeah, the sort of overall thing is still gonna be the same, right? We're still going to code gen, we're still going to write out these data structures. They're going to have like support for packing values down into a smaller range, right? And unpacking, maybe packing a float down into a floating point value that's caps within a range. We'll support pointers, arrays. We'll support arrays with a variable length argument. Yeah, we're gonna write code generate text encoders and binary encoder stuff. Gonna be good. Yeah, we're gonna have versions which are gonna be on a per structure basis, and we're gonna try and have a system which catches any mistakes. So it's gonna hold your hand a bit, but that's fine. I don't want to mess up the data, right? Or the data formatting stuff, because that's really scary when that happens. So excited for the Trump v. Harris v. Homer. Who's that last person? I've never heard of them. Are they? I don't know who they are. But yeah, I'll tune in and watch it tomorrow when I wake up, because I think it's on yeah, it'll be interesting, I guess. Always a bit of fun to watch. How about you, Sully? Right, I don't think I've seen that movie. Fair play. Yeah, so not docs, scripts. So obviously we had the entity generation stuff. This is more of like an encoder system thing. I don't know. Encode gen, maybe. Yeah. Let's just stick with it, right? So I think let's just copy paste and we'll just edit it. There you go. 3 new files. Encoded gen.c, and then we've got the batch script and the shell script. So we'll be able to run on Windows and Linux with just a case of running those shell scripts. So we just look at the shell script, it's just going to compile it and then run it. Very basic. All you need to do. Let's go to the other one, the bat file. That's the Windows one. And there we go. Yeah, so now let's actually open up the encoder generator. So we're going to change it around a bit. It's obviously not yeah, it's going to have some similarities, I think. But yeah. So we'll have this exit reader error, so that'll print out like a line number and a column number with an error. Vector type, this thing doesn't need to exist. Right, so these have a structure called like prop. So I think we might have, something that was missing from that document, the encoder docs thing. Yeah. We probably also want to support enums in here, right? So we'll probably have structures, enums. I don't know if we'll have type defs, but we might do. Yeah, so we're not gonna obviously write like a proper compiler one. It's just gonna be a bunch of strings because it's just easier and it just does the job. So we'll probably just have like an enum type, which stores like an enum and all its values. You have the identifier as a string, and you just store a lovely array of these things, right? Yeah, so we'll probably have a core string. So you could do like values as well. So maybe well, how's the value? It's just got two strings, name of value maybe. See, I don't know whether I should make it like a proper parser or just do strings now because, or we're just code genning, right? So I think just putting strings together is probably okay. I don't think I need to analyze the values and operate on that. So the string for the identifier and then a string for the value. So then we'll just have a lovely array. Union. Yeah, it's in serialization. So if you have a union, it would have to maybe be a tagged union, will it? Well, no, you just read out. Are you talking about my shader compiler, Sully? Damn it, these people. Right, I'll get him. Right, that should do it next time it happens. All right. Yeah, a union is an interesting one, right? Because say if you have a union of a piece of data, right, you've got two different sized things. One's a float 32 and one's a int 64 for some reason. One's 8 bytes, one's 4 bytes. Like the way we serialize it out is yeah, they all could pack stuff at different sizes. So it would have to be like a tagged union. So maybe we could support tagged unions. Maybe. Yeah, that is a possibility. I don't think I need it though, yet. But if I need it, we can always add it. Yeah, so an enum will look something like that. And then we'll have like a strut for strut. Um, so it's more like a strut field, isn't it? Cool. So you'll probably have like a data type and an ident. See, my concern is these data types will probably have to be parsed properly. I wonder. Because going back to the plan, if we support stuff like this, you have to parse that data type and be like, we want to probably report an error and say that when you try and take one integer and say it's supposed to be encoded as this integer instead, yeah, we have to know how to do that, right? So yeah, we need to. It's not as simple as a string, so maybe we'll do a bit more of a proper parser. Hey, Roboto. Hey there, Gol, Gara. Yeah, game that engine in C. We're currently building a little code generator for our encoding and decoding stuff. But yeah, we have things already. We have like a UI system. We've got basic 3D. Oh, is this thing not going to build because of that damn USB cable? There's a slow USB and it's causing me problems. But yeah, we've got some like 3D rendering, ray tracing some ellipsoids. This is the entity system being tested out. We've got PBR as well, physically based rendering. But yeah, just getting some more of the core system set up. Helix is pretty good. There are a few things about it where it's a bit weird. Like if you put a comment down and do a new line, it doesn't carry on with the comment. But it comes, built in with like quick ways to search through files and things, and it's got like an LSP out of the box. So it comes built in with a bunch of fancy stuff, but it's sometimes missing a few of the basics. But yeah, that's right. The config file is also a config file, right? It's not a fully programming language. So that's good. It's surprisingly annoying to implement. Yeah, I guess it's a little bit manual, right? For crying out loud, this thing. Bad USB. I don't know what's going on. It looks so damn blurry as well. It's bloody annoying. I'll fix that next stream. Great. Yeah, I didn't show off my UI thing, but anyway, it's there. But yeah, it's alright. Doing UI is okay. Once you've done one, doing more is not that bad. Same with lots of things in programming, right? When you've done it the first time, it's gets a lot easier the next time. And with UI, your alternative solutions is used some really bloated thing. So I was sick to run my own UI really. Yeah, so I'm wondering whether we should do, be a proper, properly parse these things. So for enums, when we parse the enums, right, you've got a value and a name, right? If the name, we haven't really thought about enums, but in the structures, when you change the data type, it was a problem. But if you change the default value, wait, yeah, it's not a problem. But in the enum, if you change the value, is it going to be a problem? Yeah, if you change your enums values, it's going to be a big problem, isn't it? Like it's going to break things. So we should probably have a proper parser. Because it's, yeah, so we should probably parse these things. Well, at least for the enum, we need to. There's also another kind of data type. We should probably call this like an enum type. So we probably also want to have another kind of type, which would be, would it be the sort of basic type or intrinsic type, whatever you want to call it? Because that one could. So when you define one of these, or maybe, so maybe there is the basic type, which will probably just be an enum, but there's like a kind of data type where, cool. There's kind of a basic type that allows you to say, pack it down into a smaller thing, right? So that's interesting. So we should probably call that like a packed type, right? Or yes, I think there'll be a basic type enum, which is just hard coded something like basic type U8, right? And then you copy paste 16, 32, 64. Then you want to do the signed versions. Then you also want to do the float ones. So we've got those, right? Then we need a new one, which is maybe called like a packed type. Now, a packed type always takes a basic type. I don't know what to call it. The packed type seems to be pretty reasonable. So this will take a basic type on the left, and then you would take, or maybe there'll be a packed type. No, we'll do a packed type. Yeah. So we'll do the sort of the basic type that it's the standard, the type that it is in the source code. We could call it the source type or the unpacked type. Then, so that'll be this one here. So that'll be the unpack type. And then the pack type is this. And then it's range, right? Give us unpacked range. So we probably need a union of things. So with a packed type, it's always going to be put in as an integer or a fixed point. I don't think you would ever want. So it's always put in as some unsigned int, maybe. I don't know. Do you ever want to do a signed version? Yeah, you might want a signed version, right? No. Well, no, you always put it, yeah, so when you pack it as a fixed point, that's when you might want a signed version, maybe? No, storing is, the fixed point thing's a bit weird, maybe. You can maybe just say, right, I want to pack it into like 6 bits. So if I don't do fixed point and I just say, right, I want to do it into 6 bits, right, you would do you take the difference from -5 to 0. Sorry, minus 0.5 to 0.5. That'll give you 1. And then you divide 1 by 6, and that's the step that you use, right? So fixed point is kind of irrelevant at this point. It's just extra rubbish, I reckon. So we don't need fixed point. So that makes things way easier. So then you basically have the packed number of bits. So bits count, and then you also want to have that sort of unpacked min and max value. So yeah. So we could probably do. See, I wonder whether we should. Yeah, I guess we need a union. So union basic value. So we'll just do like a U64 uint S64 signed int F64 float. Damn it. That'll do. So I guess we'll put the basic value in here. So there'll be a min and max. Unpacked min, unpacked max. So then we can do a bit of gymnastics, and we can land on the on how to quantize any value, basically. That would be pretty cool. We do need an identifier, don't we? Also. No. So that's the thing. An identifier on a structure or an enum. Yeah, I think we will. See, the problem is. So my concern is that if we make it. To go back to here. So now that we've said that a structure has an identifier, it means it always has to be declared like this, right? You can't have an inline strut as a field, and that's okay. But when it comes to these things with these ranges, you know, maybe they don't have an identifier. But my concern is, well, I think they are going to be different for every field, so we might as well not. I don't think we should support type defing them. So yeah, we won't have an identifier for them. Right, that's cool. So I think we've got all the data types at the ready. How we're going to represent this data. Yeah, I don't think we need. It means we need to parse these values properly. But that's okay. Just takes a bit of work. So let's get the arrays sorted out. So let's have a bunch of arrays, right? We'll have the packed type. So with these fields, right? The field has a data type as a string. Yeah, so I think we've got to support data types that we don't actually know about. So for instance, if you come across like a weapon ID, we're not defining that in this file. So we need to support a basic string, and that's just some other data type. But if we parse like a U8, that's a built-in type, right? So we know that one. And then we can sort of parse anything extra, right? So realistically, maybe packed types don't need to be here. So we might have a new one called a type, actually. And this one is probably going to have a type kind. So type kind. So one of them will be a basic type. The other one will be a packed type. The next one will be a... Oh. Hey there, Pete. How's it going? Thank you for doing that. I think let's plug it up. Right, is that better? Does that come through better now, Pete? Also, I'm so damn blurry. I apologize for this. If I cannot fix this, I've got to send the webcam back because this is crazy. Like, it's so damn blurry. Can't focus on my face. It also, its auto exposure is terrible as well. Ugh. Yeah, the thing is, I got a better webcam because my old webcam broke, and this one is like way more expensive, but it just doesn't seem to be cutting it. I don't think. Oh, right. Let me unplug it and plug it back in. Is that better? How about now? Hey, Bandit, why is it ghost? Yeah, it's a bit crazy. I don't know what's going on with the camera. It's a bit annoying. I don't know if I blow it up to... How does the audio sound now? See, look, I'm even blurry here. Ain't good. I wonder what fills are on. Just the chroma key. Eh. We might send it back, to be fair. No different. Let me see if I can diagnose it this end. Right, I'll turn up. Which one do I want to turn around? That one, that's it. Right, I can hear myself, alright? Yeah, I'm coming through, right? Through. I get it looping back. Is it still the bad USB? No. Right, that boots up alright. So it's not the bad USB thing. It should be plugged in. Not sure what's going on. Fair play. Thank you, though. Man, I hate my webcam's just crap. Bloody annoying. Yeah, I might send it back. I swear these days when I buy technology, it's like 50-50. You know, I buy something. Like I bought a monitor. I spent like £1,000 on it, right? And it wouldn't even wake up from sleep mode sometimes. Like, it's crazy. And, you know, I buy a webcam, it's blurry. It's just crap. These days when we buy technology, it's just so 50-50. So you can reference a strut and an enum. I think that's it. So we've got four different kinds of types. So we're in that bad boy. Oh, there's an other. An other would just be a string. Or unknown. Or is a string that we just copy and paste around, basically, right? Nothing special. Oh, we might have default initializers as well. We forgot about that. Maybe. The field, isn't it? Default value. Right. Right, so for the type, we want a basic type. We want a packed type. We would also like a strut type. Enum type. And then other. That. So that'd be useful. So actually, wait, sorry, we don't. the things about the struct type and the enum type, what we actually would want is probably an ID or something, like an index. Right. So basically in this generation thing, which is global, what we actually want is just an array of struts. So all the struct types we could possibly ever want. So maybe we do a bit of a core stack on it, like a global array. All right. So pretty cool. So we do need to define those things. So core define stack with global array. Yeah. So they're defined now. That's cool. Yes, there'll be some more things that we need in here, like the context-aware printing pointers. This should do for now. Oh wait, we also need the fields, so we could bump allocate the fields and the values. Value. Okay. So, right, so this is all the data prepared. We've got basic values. We've got a type thing. So our fields can now say type like that. This is missing a type def. Cool. Yeah, so the job is now, right, is we need to be able to parse up a text file which declares a bunch of struts or enums, maybe some other things in the future, with that custom syntax. So what we should probably do, so I was thinking we should, end of last stream, I said we should probably do a proper tokenizer and then do a proper parser, because it is just generally a lot less error prone that way, but it's a little bit more code. But then I was thinking maybe we don't need to do a proper parser and just use the text reader that we used before and just parse over a bunch of strings and skip empty space. What's going on here? Type diff that either. Cool. So we've got a choice, right? So let's go to the things we're actually going to be parsing. Yes, this is parsing strut. So as we go over it, we just want to pick everything up and, doing it as a bit of a text reader is not that hard, I think. It's just going to have a lot of, skip white space sections. A parse data type function maybe. I think it should be all right. Yeah, I don't see any problems with it, to be fair. It will be easier. Yeah, let's just use the text reader for now. If we did a tokenizer, it would just be a little bit more fiddly. Like a two-pass system. Right, so we've just got a bunch of utility functions from the entity code gen stuff. So we've got like an is uppercase, is ASCII, is digit, verify identifier to make it an ASCII string, right? First character is ASCII, then the next load is ASCII digit or underscore. Turn stuff to bin snake case, from title case. That was useful. Print a section header for like comments and stuff, or to like break stuff apart in a single file. That's what I typically do, is have these sort of section headers. And then a print format, which is like a little custom print formatter where it just goes over every character, looks for this symbol here, and then it will check the next character, and then it just, it's like context-aware printing. It's quite nice. It really enables you to make your format strings very simple and not have to pass in a bunch of parameters, because the parameters are globally known. So I think we should do a similar thing again. So what I think we should do is do it for all these, right? You literally just do something like, so I think we'll want one for the structure type, the structures identifier, maybe. So you'll be like format strut. That's one of them. Then the next one is a format struct field. Then we're going to need a bit of enum as well. Enum value. Oh. Right. So we also would probably want to select, well, we could select type. So if you had a type that was set, then it could be any one of those, which is, kind of meaningless. But yeah, maybe we could have a packed type pointer, and then a basic type, and then an other, maybe. Yeah, we'll see how it goes, but let's just get these ones in. They're quite easy to do, and we'll see. So we might want like a 2-character thing this time, where we're going to say strut ident. So you possibly want like a structure. So you got a few things right. You'd want a structure identifier, structure value, right, to be printed out. So imagine that one as like an SI, an SV. Then you'd also want like a structure. Oh no, sorry, this one's a field. So it's FI, FV, F. So you want to be able to print out the data type, and then you also want to be able to print out the packed data type. No, packed, you might want that one, because the packed one is like 6 bits or something like this. Yeah, so I think these are some ones that you want to get strings of basically in the code gen. And then for the structure, which is here, that'd be structure ident, right? And then that's basically it. There might be some more stuff that will come up. And for enum, you want enum identifier, then enum value, so be value, ident, value. Right, so these are the shorthand two character things that we'll just quickly fill in here for the custom formatter. Be quite nice. So we get two characters. So you get char 0 and 1. I guess you just do a bit of a ch. You get if ch equal s, that's a structure. The structure field, F, then an E for enum. Enum value is the final one. Cool. So then all of these will just parse another character. So just be something nice and easy like this. Cool. And then we probably do more if statements again, or we could probably get away with switch. So you just say like switch D I V. That's a structure field. So this one will be generate a struct field. And then you would say ident but that's not for the data type though, but we'll need a way to stringify a type. So we need a function for that. So here we should probably have a way to, stringify some type. Type string, passing a pointer to a type, and somehow you get that back. But we'll implement that in just a moment. Let's just finish where we're at. So this would just simply, hang on a minute. All right, cool. So yeah. So they're always going to be putting out a bit of a string. So I guess I did a bit of a poor value. And then we'll so we'll just place near the string. Cool. So I guess this will just be something like this. Right. So this I was then struct field. Well, this was ident actually, but this one would have been that sort of type string, and then we passed in gen format the struct field data type with the address. There you go. And the final one is the value. So it's a very similar thing to the second one. This would be the default value, and that's just a string anyway, and there you go. Right, so that's the structure field one done. We wanted a bit of an SI for structure identifier. So that would just be this one here, like that. So we use the format strut in the context, and we can just use that. Cool. The next one is enum. That's just the same as structure basically, so just copy paste it. So rather than the word strut, we just place that at enum. Boom. You don't have an ident? Have a look at that one. Right, that's the longer name. Rightio, so back to where we were, nearly there. So the final one is enum value. So this should probably be more like the field. So strut field. Right, so we want a bit of an I and a V. So ident and then value. Now value is already a an integer. So really we should probably just use something like this. Oh, I messed that one up. That's cool. Gen. Sweet. Sweet. Cool. So, missed one more. U for unsigned. And then it should just be as simple as value. Cool. So, so this context that we're printing is more complicated than the previous one, but you know, should be quite nice. Should make it so that our format strings when we code gen would just be a lot more easier to understand. But yeah, so we want to be able to get a type string from a type. So I guess we just switch on the type kind. So I still okay. So this would be case, right? So for a basic type, we will have to actually turn that into a string again. So we need a lookup table for that. Where is it? So const char star. Yeah, so we just want to put every one of these in and get a string version back out. Not too hard. Cool, so we do want to lowercase that. There we go. Cool. Yeah, so that we just look up into that and then voila. So type strings. So yeah, I think we can use that return core string C. So from a C string. Type basic. Nice. Let's correct this. Great. So this next one is packed. So packed type, when you ask for a string for it, you're really just doing the basic type version as well. That'll be unpacked. It's the unpacked type, and that'll be basic type. The structure should have to go into the globals here. This will be gen.struts type strut index dot ident. Yep. And the enum is the same thing, just with enums. And then other is just a string anyway, because we don't know all the types in this code generator. We don't parse every type. So if we don't know what it is, it's just other, and we just treat it as a string, and we just believe it's okay. And that would just be good enough. Other. Cool, so that's a nice little function there. I think it's saying I'm missing count. Zero, I guess. Cool. Rightio. So now we've done the formatting stuff. So I think we should start doing the parsing now. So I don't need that sort function because that's from the old entity one. So yeah, I think we agreed on like I forget now. I thought we agreed on. Yeah, I thought I could just do it all using the text reader rather than doing a proper tokenizer, and we'll just parse it up using the text reader. Yeah, we'll just do that. It might be useful to produce some file and line information, right? Might be useful. So we did kind of brush over that a little bit. So we should put that in. So whenever you declare something, we should always have a bit of info about where it came from. So we'll call this one lock, I guess. To know, hey, well, you already know what file it came from, but I guess we just want a bit of a line and a column. So we just put, so in the structure field, you want a bit of a location information. In the enum value, you want it as well. And obviously for the structure and the enum, you want it. Oh, I messed that one up, didn't I? Cool, so seems all right. Seems like I'll do the job. Right, so should we get on with the parsing and parse up some things? So maybe we should have a bit of a testing one to do. You know, so source, logic, I guess. So you've got entity. We're going to be doing probably some kind of levels or something, or prefabs levels. Yeah, so maybe we should have like maybe a level folder. I don't know. Well, let's just do a test one, right? Yeah, let's make a new file. So the new file is just going to be called test and dot encode. And we'll just write some stuff in there, and that's going to be our thing we're going to test with. Create a new text file. So this is our new thing that we are going to be code generating from. So let's bring in some of those examples. So yep. So can I tell it to syntax like C? No. That's a damn shame. Can I helix? Because in Vim you can do that. Merged a few days ago, which implements this. Set language. C. Yes. Easy. Yeah, demonstrated. Vim was too much. We needed it to step away from Vim, but we needed to keep the modal experience. Hey, cell phone. How you doing? Yeah, it is blurry, isn't it? It's blurrier than my vision as well, so I've got a double blur. I think I'm going to send the webcam back. It's annoying. I think the autofocus is a bit messed. Look, see? If you do that, it focuses fine. Bloody annoying. Hey, Cat Pain. My cheap webcam was better than this expensive one. Bloody annoying. This has got too many bells and whistles. You know, it needs less bell, more whistle. Like, no, sorry, it needs less whistle, more bell. I don't know why it's just so bad. Let's dig into the properties. I don't think I've missed anything. There was one to do with focus, actually, I think. This might be it. But you can't drag the slider. Wait, that's exposure. Don't do this. Huh? These things. Damn it, software. See, I put it to 100 now. Yeah, I don't think this is helping. What made me find it pulling the trigger was I updated my system and then my custom configuration didn't work anymore. There was some plugin that broke, so I was like, script. And I was looking around and, you know, I tried out some, I stuck on some non-modal editor for a bit, but then I just came over to this modal one here. It's quite nice. There's a few things that it just doesn't quite do. Yeah, it was definitely the flip the table moment that made me do it. Is there an automatic option? I didn't see an automatic option. Oh, there is. But I don't know if this setting applies to this camera. Like it's probably not hooked up. We'll go. In it. Back to the Amazon you go. I might have to be webcamless. Well, I've got the old one here, but it is cut out. Yeah. Here's. Right, so we're going to imagine there's like an entity, support some kind of aliasing thing probably. Versioning, I think I want to make that auto magic. You don't know the version number, it's just auto magic. So aliasing, we can alias fields as well. Yeah. See, aliases are a bit bananas because you could probably delete them after you've generated it once. Yeah, we'll keep it in there. You know, let's not bother with that for the moment. Right, but let's aim at trying parsing this. Well, there is a hex field. We wanted the variable length arrays, wasn't it? Hang on a minute. This bugger. Yeah, then a bit of a level. So, yeah. We should also test an enum. Enum entity type will say, I don't know. Let's just test some random stuff out. Person, frog, wagon, and then maybe a cow. Anyways, you get the message. We should probably hard code these things, right? Because otherwise you can't reorder things. And then if you remove them, like there's a thing where you never remove fields, but I guess you could do versioning. And then you could do the upgrade where you go from the old one to the new one. But then if we went from the old one to the new one, then what would happen is, yeah, you'd need like a V1 or a V0 suffix. So maybe you don't need to do this, and we can automate that whole process. Maybe. It gets a bit weird though. Yeah, we'll automate putting the prefix on. Mm, right. This is pretty cool. Yes, I think there's like a dev flag as well. That's what I wanted to do, put a dev flag down to say that I'm changing this. Um, yeah, something like that. Right, so let's start with the enum. So basically, we're going to hard code some file we want to parse. I guess we'll just have a bunch of files in here. So, we'll probably have a function which just does it all. So this will be the parse. I guess you have the parse and generate function. And you probably just have a file path passed in. So basically, we're going to read in a whole file. So this is going to be the thing we're going to be reading from. I guess I'll call it a layout. We'll initialize the text reader, 0 the generation structure, the global generation structure. Right, get away const. Yes, and then we need to initialize all those things, isn't it? I wonder. I need a custom allocator function. Right, let's get into my cores and implement one of those custom allocator functions. Yeah, so we're just gonna roll with the, we just use malloc, right? So we go if allocated, free allocated, else that return null, else malloc size done. We're not going to need to worry about aligning it because it's already going to be aligned to 16 bytes, and we're not going to be going over that alignment. So we'll just do a bit of an unused instance and a bit of an unused. How do you go the other way? Everything's going so wrong. How do you go backwards in Helix? Is Control N like NeoVim, but it's not like Control P? Well, we already know, right? We can do this. Jump backwards on jump list. Oh, right. Yeah, that was my own one. But here, this is in insert mode. um, yeah, I don't know. Hmm. Well, I'll find that one out. Right, so unused. We're doing the line. Right, cool. So we can make the custom allocator now. Should be quite easy. Allocator. So instance is null, and then function equals alloc function. Boom. Vault speed good enough. So when we should initialize all those stacks, so call stack init. We're going to instantiate gen dot struts allocator. How many struts do we want? 1024 ought to be good enough, right? That should do it. We'll repeat the same thing again for enums. Strut fields, and then enum values. So we all right, so that'll just be probably 496. We could probably allocate more, it won't matter. But well, let's do 16k of them. Cool, so they're all initialized. So now we need to begin the actual parsing of the from the encode data description file. So we're going to extract all the stuff out now. So this is the old entity one that we wrote last week or something, or 2 weeks ago we started it. So we're just going to edit this and change it around. So we're just going to use the text reader because it's just easier. So this basically is just going to loop around and it's going to skip all the white space and new lines. And if we're not reached the end of the file, we carry on. Then we parse the first keyword. So in this case, it'll be a strut. And then there'll be another one for enum. What else is there? I think that's it, right? Yeah, that's it, strut and enum for now. So how do we want to handle this? So if you don't do that, you would get an else statement. Yeah, expected enum or strut. We got this, right? Cool, so let's delete 1/2 of it. That's pretty bad. All right. Yes, we'll figure this out. So basically, we would like to. So let's start with the structure one. There's like. Well, we was going to do enum, but enum is easier. Let's do enum. So there's an ident. So this one would like bump allocate a something. So we say enum we just call it E. We're going to do a core stack push, bump allocate, gen.enums. The bump allocates 1 will 0 it. Well, it should all be zeroed, but we'll 0 it anyway. Then we would like to there we go. Right, so then we want to skip some white space and pass the identifier. So we're going to take this. So we're going to store an E ident. So we're going to read the characters until we reach until we reach a hash or an open brace, basically. We don't really care about the new lines or anything like that in this one. So either a hash or an open. So if it's zero sized, then we have a problem. Yeah, then we should have skipped some white space though, mind you, beforehand. See, this is the problem with doing the text reader approach, but it's all right. Will be good enough. So yeah, we should say expected identifier after the struct keyword. Hint, and we can just write our little structure, right? We could say strut, banana, and then do a bit of a tab, do a bit of a, you have a banana's age. Cool. So yeah, we'll be able to like exit with an error there, and it'll say at this line number there was a problem, and then it would give you this sort of reasonable error here. And then we can just verify the identifier. So we pass into this verify. So we saw that earlier, right? Just make sure it's ASCII with underscores and stuff like that. It should be able to start with an underscore, but I don't really care about that. Right, so we keep going after that. We then we parse all of the different hash stuff, whatever it's called, like a directive or something. So we skip some more white spaces. Technically, it could be white spaces and new lines, right? So we should probably change out for that one instead. Then after that, we're just going to get the, we check, and we're trying to say, well, no, you should always go up to a space or a tab. That's when you're stopping at, isn't the next bit of white space, isn't it? You don't include white space in it. I guess so. So I guess it would be that as well. Yeah. Fair play. Anyway, then you skip the white space. And then you check the ident. So what you're saying is, am I the character that I'm on right now? Where do we do that? Compare char, that's the one. So we check if we've got a hash. Then we get the string. Yeah, we're on all this code here. Good piece of code. So we're checking. So we scan until the next sort of delimiter, and we are so incomplete directive. So here I guess we're trying to say let's just copy that, paste it here. Cool. That'll do. And then here we can start parsing it. So this will say that it is in dev mode or something. Something we've still got to iron out. So that would then mark the type. Is dev mode or something like this. We'll get into that in much later on, I think. I think we'll actually just code generate a bunch of like serialization stuff first before I worry about the system which helps do versioning and that'll probably come later. It'd be better to get a working serialization system first rather than dealing with like versioning. So getting back to where we are with this generate thing. Hey, why did I started editing the wrong place. Right, we'll keep doing it here, but we'll move it up to there. Yes, the idea is this will just set that sort of E is dev mode true. Then, did we have like an else statement in the previous one? Yeah, we did, obviously. Right, so we'll nick that. Yeah, cool. Unrecognized directive. I guess we'll do the banana thing again. Banana. Right. That'll do. So we can have more directives there in the future. That's pretty cool. Then the next token, if you will, would be a just give some more white space and new lines. And then you should be able to get to a. We should be ensuring that there is a open bracket. So something like this. So if that does not exist, then we need to say to begin defining a struct. We'll do hint banana. Cool. So after we skip that one, we skip some more white space. Just keep going. Now this is where we do the for loop over all the fields, or another while loop. So we're continuing while there is you know, we should be able to at least peek some more things. So if we can't peek, then you've got an unterminated. You haven't correctly terminated the thing, right? Expected this. Right, end of file reached without terminating a strut with this. Hint. Cool. Nice. So what's after this one? Right, so then you want to parse the data type, right, of the field, and then so this is where we do the parsing of the data type code. So it does get a little bit crazy here, I think. Maybe we can break this out into different function, so it just keeps, you know, maybe we just call it parse type, and it just returns a type or something, and you give it the reader. Yeah, we'll see how that goes. And maybe you have a pointer out for the type, and you return a boolean. No, but it'll exit on an error anyway. So we should probably just be able to say e. Wait a minute. I forgot. I'm parsing an enum, not a strut, and I've been doing structure this whole time. Right, no biggie. We just swap this out for strut. Right, we'll do enum next. Hey, Zaka. Yeah, doing a bit of a custom parsing solution. Basically C, but it's going to have a little bit of extra bells and whistles to sort of like, yeah. So it's going to have ways of like doing versioning and of data structures and re-encoding. Like this is the type that it is in the C file, but I'll be able to pack it down as a U8, or you can pack it down even lower as like a U6 or something if you wanted. And then you can give it a range to do the packing into, right? So yeah, it's going to be a bit more of a. Okay, we don't do this versioning on things anymore. Versioning on struts only. Yeah, it's a slightly custom format, but it's basically C, like pretty much C. I think it's something like that. Yeah, it does, I believe, have reflection in that. But yeah, sometimes it's good to have stuff as custom though. But I think what's great about Jai is you can get those tag things, which basically mean you can put anything in there. So it's actually quite flexible. Whereas I think some other languages you don't get ways of defining sort of custom attributes, you know? That's pretty cool. Yeah, so we'll parse a type, and then we'll parse an identifier. So I called it E here for a minute. There's S for strut. Yes, we'd say S type. Shoot, it's on a strut field, isn't it? So we need to allocate a field. It says bump allocate a field out. Do something like this. Oh, I messed that one up royally again. Right, what we're doing. So I keep forgetting my keyboard shortcuts because I don't use this all the time. Whereas bump allocate a strut field. Cool. So we'll parse the type into there. We should put a location in there. Excuse me. So we should be able to have a way of saying like drop a location on there as a lock. Pass in the reader and it'll construct one and return it. Do we need that for the structure as well? Like, hey, the struct was declared here. And then we also would like a way to parse the identifier. Here, this sort of code. So we also need to skip a little bit of white space as well. Right, radio. And this one's looking for the semicolon. No. Well, the semicolon definitely needs to be at the end, isn't it? But yeah, so expected identifier for field. To name the field. Something like that. Nice. So that'll go into SF ident and validate that it is correct. We're looking for maybe a semicolon afterwards or a space or one of these tabs or new lines. And then we need to do another one of these like, well, if it's not a semicolon, we have ourselves a problemo. Yeah, so expected a semicolon to begin defining to sort of finish up the struct field. Now, let's be honest, there's also that hexadecimal thing as well. Yes, there's also that hash thing as well, so we need another one of these. So after the identifier, you can actually start declaring another one of these sort of like hash things. Hash. You can start declaring another one of these hash thingies. So here you're looking out for until yeah, semicolon or a space. Yeah. So incomplete directive. So I can do that sort of age thing again. But with the hash, so it'd be like hash hex. Display in hexadecimal. Hex. And then we can put a Boolean on here that is hex. So when we do the text writer for the serializer, right, for the text file, we can print it as hexadecimal. Right. So that'd be like a is hex unrecognized directive hint age hex. Nice. So yeah. After that, you do some more white space stuff, right? Just the nature of text readers. And then so after you've parsed that, you would have parsed it. White space, new lines, go around again. Right. We're missing a way out, basically, right? So you can declare this here, and you say looking for a close. And if you found a close, you can break it. And voila. Look at that. So that should be able to parse a structure up, but we got to be able to implement a couple of these functions. So there's this location one that was pretty easy, then this parse type one. So yeah, so the enum one is basically a copy paste of that one, changing a couple of things around. And then it should be quite easy to get up and running. So where is oh, we're doing that for. Right, so we would like to make one which is called lock. Returns the location. With a reader pointer. So lock line equal reader line. And then column equal reader column. Then we just return the location. Now we'd like another function which parses a type. This one was called parse type. So it takes in a reader, I think. And it returns to you a type. So what we need to do is do a whole bunch of checking, basically. So we've got these basic types, we've got these packed types, and strut type. So the easiest one, so the most common would probably be the basic types. But then if it's a basic type, you need to check to see if it's a packed type. Then if it's a packed type, you parse that, and then you return. And then if it's not any of those, you can parse the structure or enum, right, search for it. And then if not, it's just other. So it should be quite easy. We literally do a check for we want to parse an ident, right? So we're looking. So it could. So because this is like a structure field or something like that, there'd be any one of these new line things or an open bracket for that packed stuff, right? Because the packed stuff can do stuff like this, right? It can say how you're gonna pack it down, right? Maybe you need to use the word B, binary A. Cool. Yeah, so you you parse the yeah, so now you got the ident. We do need to verify it. That is for sure. And we do probably actually need to say if it hasn't got anything, I'm going to exit with a bit of an error. For type name. Something like that would do. So we're looking for identifier. Okay. So now this is where we do all the checking, right? So we say if I would like to compare string equal literal. So we go ident u8, right? Is equal to u8, 100%. Then we've got a basic type. So the idea, right, is you want to probably have a thing called a basic type here. Initialize it to something a little, you know, an invalid value. Then here we'll end up setting basic to, so I wonder if we can. No, we'll probably have to do it another way. Right, U8. Nice. So if we simply repeat a few times, 16, 32, 64. Right. So we search for 8 and we can just multi-cursor it. Oh, shoot. Mm-hmm. 32 and then 64. So we just have to repeat that for the signed version as well. And then for the floats. Well, I kind of copied, we don't have float 8s or float 16s. So that was a bit of a weird one. Right. Cool. So that's all the basic types. So then down here we go, well, if you did end up getting a basic then, check to see if there's that open bracket. And if there is the open bracket, then it's a packed type. So if you did get one of these guys where it's just not equal to count, then that means, you know, at the end of the day, you will return basic if text reader read. I don't know why doesn't it work? Read char in it. Compare char. Right. Reader. The char will be an open bracket. So if it's not that, we're just going to return the basics. Well, no, you've got to dress it up in one of these. So you go sort of like height, open, kind equal, type kind, basic, basic, basic. Right, okay. Nice. So from here on out, this is where it becomes the packed ones. So we've just got to pile all the packing stuff. So we'll make that lovely local variable, packed type. So this one has a basic field, untyped, so unpacked type, and that'll be basic field. Got a few more. It's got one known as unpacked min, unpacked max, and bits, so the number of bits. So the first thing we parse is the number of bits. The first thing we parse is a number of bits. So we should skip some white space here. Yeah, so we should allow it to skip all sorts of white spaces and things. A little bit strange, but yeah. So after we parse the char for the open bracket, right, so I guess after this function, it's already going to skip the white space. So we do not need to do it again. Cool. Right. Yeah, so we parse. So it should be like a U. So the way that I thought about it, at least. Nah, not tokenizing it first. I just can't really be bothered, really, because it would have just been, you know, more work doing a tokenizer and then turn, you know, it just would have been easier just to sort of get down into it and just text reader it. But the tokenizer code will probably be more readable, like the parser section of it will be more, you know, but yeah, it's not, you know, there's not that much complexity. We'll just be parsing, yeah. Mm. Yeah, we didn't really put pointer type in there. And arrays. It's another one. Yeah, it does have crazy array and pointer to text in it. Yeah, I'm not going to support array of pointers, I don't think. Because like when you try and serialize a pointer, yeah, we try and serialize a pointer, that'll be fine. It's gonna... yeah, it's just gonna... I was wondering how would I store it in the... I'd store it as a pointer type to the other type. Yeah, I'd have to... Yeah, so I'll probably just parse the pointer. I wonder. So when you parse the entity, you probably could bump it to the other end or something in the binary file. But for the text file, I guess it could just go all in line. Yeah, I'm not sure about pointer types. Maybe we can skip those for the moment, but array types will be easier. So until I need pointer types, maybe we can skip them. I don't think I'm actually going to need them. But yeah, let's just do arrays. So I did miss the array type. So you got to parse the array bit after, at the end. So it's a little bit annoying. We could, of course, change the syntax though, but still. We should try and keep it as C-like as possible though. But yeah, the array type would just be another one. Does it need to be C-like? I guess it's just easier to, because people, it's just easier to keep it in the same format, right, where possible. So like array tab. So an array type. It'll just store another type in here. This is the element type. You would then store the VLA name. So either you'll be a U32 the number of elements, or you would store the VLA. I forgot why I called that in the end. Where's the sort of plan? VLA name. Okay. All right, I think that's all right. So this would probably be declared along with the structures and the enums, and then we'll probably have an array index, array type index. Yeah, so in the generator we'll just have an array of arrays. Nice. Just got to parse that syntax. It's a bit funky, but it's all right. Cool. So parsing the type. So when you've finished, it could be an array. So we just go to finish instead. Right, so at finished, we can just do all the bits. We can check to see if there's a wait. Parsing a type would be different though. You have to parse the array bit after the identifier. Okay. And then make it a VLA. Or make it a an array, which could be a VLA. Okay, that's cool. Right, so after we've done the open bracket, yeah, we're going to parse the packed stuff. So I think do you want to do U8 there because it makes it seem like you could put any type there. So really, this is meant to say the number of bits that you want to use, right? And then the other two are like actual values for that type. So if I say B8, maybe for binary 8, maybe that's all right. So what we're expecting to see next is a B. And then followed by a number of how many bits. So we don't see a B there, a magical B. We have a problemo. Expected a B to define how many bits for this packed type. So you then say hint or a new line hint. So we say U16 B8 100 to 300. Like that. Cool. So yeah, then you parse the number. So we don't really have a parse number. But yeah, we just want to parse like a couple of digits. Yeah, we should have a parse int or parse number function, which gives you back something. So I don't really have one of those yet, but we should get one. So it should be called like parse number. And it should return a basic type. And it should also return a basic value, which is a union of a bunch of values, types of values. So yeah, we'll just parse a number out, basically. So here we need to get the so we'll just say basic parse number reader basic value. So basic and then value. So after we parse that, we do the checking here. We want to make sure that the value that we've parsed is an unsigned int. So if it's not an unsigned int, problem. Or maybe we could say, that's cool. To be followed by an unsigned int for the number of bits for this act type with a lovely hint. So yeah, we're doing like if basic is not equal to, that I guess a basic type out, isn't it? Yeah, we probably need a way to say if it is unsigned. Yeah. Didn't have a lookup table. Cool. So we can just look that up and quite easily figure out. Oh. Yes, that's in parse type, isn't it? Yeah, so here we just say parse num if not, get her in there. So it's not unsigned. Nice. Now all the values, we can just say parser dot bits count is equal to value dot unit. So we're still going to write that other function, but it's fine. So we parse another number and another number, right? Well, I think it would give you back a U64. I don't know. The lookup table works. Yeah, so when it comes to like you just want to keep parsing numbers now, right? You want to go, a little bit of comma. So we'll skip a little bit of white space again. That it would have parsed up to the space or something like that. Then you do more white space. If there's a not a comma. Set the comma to define the minimum value for the unpacked, the minimum unpacked value. Something like that. So we do that here. We parse the next number, and we want to ensure that it's got the same kind of class, if you will, right? Is it unsigned int? Is it assigned int? That's probably a better way of looking at it. To the basic type. So really, I think we should have another one of these. What do we call it, like a class or something? I don't know. Maybe uint, signed in, and then float. Yeah. Someone tried to advertise. Amazing. Right, so this class thing would be useful for detecting if two basic types have the same, and then we have to make sure that it is in bounds as well, for the type. So there'll be another function for that. Like a verify is in bounds. So I think we can actually just get it to return a class instead. So, this will turn like the uint one, right? Pretty nice. These ones will return signed in one. And that'll return the float. So now we've got this sort of like class lookup table, which would be quite nice. Right. Cool. So that is unsigned. Is now it does the class lookup instead. And we just check not equal to unsigned. Cool. So now what we do is we say here we want another check. So after you parse the middle number, right? So after sort of the minimum number, you need to make sure that the class is the same as the unpacked type. So you get the class of the unpacked type. And you make sure it's the same as the class of the one we've just read. So it'll have to be a floating point, right? We're not going to do the implicit conversion. But yeah. Yeah, so this one's going to say expected the minimum unpacked value, or we should say, right, unpacked value has or is a, and you say string, but the minimum unpacked value is a blank. Class mismatch. Oh, I don't know. Yeah. So Make them all the same. Cool. Right. So we need to put those strings in. Pretty easy. So go back up to this basic, or this class thing. Find some more lookup tables. You know, we want to basically like basic class count. Lowercase. Sweet. So we've got some strings there. We can just print them out in a nice error message. So something like basic type class. Wait, basic class string. Pack dot unpacked type, and then the same thing again. With the one that we just read. Sweet. So we're nearly there with this packed type that we're parsing. This is obviously the most complicated one. And the array is the second most complicated. And the strut and the enum is just searching for some strings. But yeah, I'm just gonna take a quick break, get some more drink, and then I'll be right back. Hello everyone, welcome back. There we go. Yeah, so after we've parsed the number from this sort of like packed type, the minimum one, we've got to make sure that it's in range. Based on the actual type of the unpacked type. So we would probably want a verify int or verify value. Hey there, Avik. Thank you so much for the raid, sir. Appreciate it. How you guys doing? Welcome, raiders. We're currently working on a little custom parser for a Serialization system. So yeah, just trying to parse up the file right now and get all the metadata about these structures and enums that we're declaring. Yeah, how did the stream go? Appreciate it. Yeah, how did the stream go? Hey, welcome. Verify basic value. So it's going to take in a. Well, you don't want the reader to come in for the error. We're parsing the basic type and the basic value. Yeah, so we're verifying that. Again, we've got to write it out still. That's to do. So that's go to parse number. Rightio. See, we could probably say use up to 256 bits. I don't know why you want to go over that, but well, 64 is the most. You make sure it's a uint, then verify it, please, with the reader. The type. Yeah, the value. Cool. So after the minimum, just put my Vulkan GPU particle demos to web GPU. Fair play. Cool. Almost got it. Had to reduce the overall particle count to 8 million for web build compared to 10 million. Okay, it's not that bad. Yeah, that's cool. How are you finding web GPU? And are you doing it using like WASM or something? WebAssembly. Is that right? Yeah, so we're building a little custom. So I've got this file, which is basically a C file, right? Where you can declare structures and enums. It's slightly different, I think, but it's mostly going to be the same. It's mostly just got additions, so we can support. It's got like variable length arrays. It's got aliasing field names. It's got a special sort of like packing syntax. And it's got ways to say I want this in hexadecimal for a text file. So it's got ways of being specific, features that are specific for write out to text file, and also features that are specific for write out to a packed file filled with ones and zeros. So we currently run the parser for it, but with last stream we did a whole plan where we've thought about like all the things that I want and how would I go around about and implement some of these things. So we planned all that out. There are still some things which are not 100% sorted out, but yeah, the hope is as I write, I can figure them out just as I start implementing it really. So we're just trying to get this parsed up because this is all the features that I want, and then we're going to go from there really. So the serialization system is, I'm going to be creating content. So one of the things is as well, I just want to make sure that when we create data, we don't accidentally make it so that I lose all of my data. Right? I want to have a system that's upgradable and maintainable over the time that we change data. And also try and not make so many mistakes while doing it. So I'm just going to write out all the stuff which does the serialization bit, and then the versioning bit will come after. Yeah, so after we pass the number, we do a bit of a verify. Yeah. Cool. And then after you've done that, you should be able to say packed dot unpacked min equal equal value dot. It's just value because it's one of those union types. Cool. Yeah, we're ensuring it is that. The thing is, though. Oh, you make sure it's the same class. That's cool. Right. Nice. So the max value is the same thing. We literally just copy, we literally paste, and we literally find and replace. Maybe I should upper this, you know what I mean? Bit of upper. Just to make it a bit more distinct. Right, so that is basically, that is basically the packed type done now. So that will be parsing that sort of special packed syntax. A little bit complicated, right? But, that's parsing for you. Parsing text is, it's always a little bit longer than you hope. Parse num basic. I should have done a new lines. Right, so we obviously haven't implemented those functions though, but we'll maybe save those for the next time we stream. But let's just put some goop in here, and then I won't accidentally forget them. It'll be a bit of fun to do. So some more types that I've missed. Yeah, so the next ones are doing the structure and the enum, and then other is just default, right? So we just literally scan. I could speed this up, but I don't need to speed it up. So we literally just scan over index 0, core stacked counts of gen.structures, and we basically just check the strut. Let's see if we got ourselves a match. So we go if gen.structures, right? Identifier. If we just do a string compare, right? Isn't the best, but let's do it. If there's equality with the item that you have, then we've found ourselves a structure type, right? So we literally just return it as a struct. Wait a minute. Yeah, I think I didn't want to support nested encoding types. Oh, no, I did. Yeah, but those ones can't have default values, that's it. Something like that. Yeah, so strut index, right, index, and off we go. So the enum one is exactly the same. We simply just replace the word strut, enum. Cool. So if we have parsed the type and we can't find anything else with it, it is just an other type. And an other basically means just treat it as a string. And, whenever we refer to it, it's just a string you paste in, and that's it. So there's an other type, and it's just The identifier just goes in there. That's it. There's one thing that I did kind of miss that I quickly remembered. We expect a closing bracket here, obviously, right? An unclosed bracket. To finish the pat type. Bum, 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 bum. You know, what could be quite nice is we could put like hints, like arrows underneath that point to the things that we're talking about. That would be quite nice. Obviously, they won't be colored. Well, we could do them, make them colored, but that just makes it way more complicated. But yeah, that could be quite interesting and a bit of fun. I might do that when we actually try and debug it, right? Because I've got to debug every if statement and make sure it works. Because we don't know, you know, this is to do with data. So I don't really want to mess up this stuff, right? You know, test your code. Cool. I think we're in a good place there. So I should always skip some white space before it returns, I think. Yeah. Nice. Right, so I think that was parse type, right? So we did all the struct one, wasn't it? Yeah, I did the struct one, then I was like, let's implement some of these functions. Then enum we didn't do, obviously. Let's get rid of all that. We still want to do enum as well. And we probably want to print out the stuff that we've extracted to sort of like just show that we're not missing anything that we've parsed. So let's just spend a bit of time and implement some more of these functions quick. So verifying like a basic value, you basically just switch on the type and just make sure it is within a range. So I guess you can just switch. I don't think I've done this one yet. So this will literally just be a case. And easy as pie, right? So we just say if you go if value dot uint. So there's also signed ones as well. They're a bit different. But let's just say if it's greater than or equal to 256, there's a problem. So we'll just print out the fact that we failed. Or maybe we say, no, we'll do a proper nice error. So we'll go here and then do like the exit reader error reader. And the format is going to be, so put the basic type name. Now, so we put in that, we'll lowercase it, U64, or say value, So value.uint, and then you want to do something like must be in range from 0 ... or 2, and then we'll say 255, right? I got that value. So the signed ones obviously need a bit of extra stuff. But yeah, this is basically it. 65536. 65535. 4 billion. Oh, look, it's Rust. Well, I could just do I could write out in hex, to be honest. Nice. And then for the U64, we cannot fail. We already would be overflowing the maximum number when we parse the integer. So U8. Yeah, so I forget the S-mins. Well, I do have a bit of a signed in. Ah, so you can do it with the mouse. Interesting. Nice. Right, so do a bit of a signed in. So you say if value dot signed int is less than I think it's like 120 minus 128, I think. I forget. Something like that. Right, let's go and find them. Yeah, okay, so it's minus 128, but I need to go if it's less than. Yeah. So 128. Cool. Minus 128. See, I don't know why I did the equal sign, to be honest. It could have just stayed the same number. Right. Yeah, all the way to 127. So then that'll be 32768. 32767. I think that's right. Three two seven six eight. Yep. And it's had 2 billion number. 32767. Bam, bam. Where is it? There we go. The max. There we go. Right. Just drop these boys and girls in there. So the sign 64 probably doesn't go out of bounds. That's done when we parse the number, we go, oh, it's overflown. The maximum possible one. And then for a float, so when I say like verify a basic value, what am I saying? What am I using that for? Oh, yeah, the class is checked. Yep, that's good. Cool. Yeah, sweet. There's another one, which is for count, which I missed, which is basically just telling the number of enum values I have, but it's an invalid value, mind you. Right, so that one has been solved. That's good. Oh, we're missing an array. Well, printing out the string for an array is yeah, the type string for an array, you just build, it's a little bit more complex. So you go element type string. So then you fetch the array type. You pass in array element type, get that to be parsed and return. Then we do a bit of a funny I can build a string with this. So I build it with the name of the element type, crap. And then I guess just put the arraylet after and the number. Maybe a number. Sometimes a number, sometimes a VLA. Element. Right, it says if we have an array with elements, if not it's a VLA, and we'll return something a little bit more different. So this will use the VLA name there. A VLA ident. Cool. So that custom allocator thing, we kind of put that local to a function. Bit weird. We'll just make it global. Make things a little bit easier. Just make it a global variable, no biggie. Right, so making good progress here. We're still got to parse a number that's a little bit more involved, but it's, relatively straightforward to do. And then yeah, so here's our file, right? We've got enums to do still. But that's basically copying the structure one that we've done, and it's just far more simple. Yeah. Then so do that parse function thing. And then parse enum. And then after that, we can debug print it all out just to make sure it's all parsed correctly. Have a bit of a play, make sure it's all the error messages are kind of nice and trigger correctly. And then we can move on to actually generating some code for the serialization. So we'll have like a binary serializer and a text serializer. So we'll probably have to write some API for those, and then the code that we generate will simply just, call that API, and we'll have a lovely set of functions for each type. So yeah. So the next stream will be on Thursday, 7:30 p.m. GMT +1, where we'll hopefully get it all parsing up and maybe start work on writing some kind of serializer or something, or or just code generating the very most basic thing. So finish up the parser, code gen the most basic thing, and then we can start writing some serializers and having some fun with that. Cool. Right, let's drop a link for the Discord if you're going to come and hang out in the meantime. But yeah, let's find someone to raid quick. Yeah, I hope you guys have a good Wednesday. I'll see you all Thursday, hopefully. Well, why would you sit there and just like talk to a bot and get code? I do not understand. Just program what goes on. Right, I can't find someone to raid. Just gonna bail. Right, have a good night, guys. I'll see you all in a future one. Catch you later. Thank you.